Hello class. We're going to be working on graphing and evaluating exponential functions today. So we're going to just jump right into our notes and get going. Should be fun. So what does it mean when we say we're going to be evaluating exponential expressions? That means that we are going to take these exponential expressions and we are going to simplify until there are no more exponents. That's an S. So there are no more exponents. Sometimes that means we can use a calculator, such as an example A. When we take 4 to the third, remember that means 4 times 4 times 4. Or you can use your calculator, but 4 times 4 is 16 times 4 is 64. We evaluate that, and it's just 64. If we want 6 to the negative 2, we can do that in a calculator. In fact, because I want it in a decimal, you probably will. But just so you remember what negative exponents mean, that means if it's in the numerator, it has to go down to the denominator. If it's in the denominator, you're going to flip it up to the numerator. So this would become 1 over 6 squared, or 1 over 36. If I want that in a decimal, though, I'm going to put that in a calculator, and I get 0.028. Now this one, that 1/3, what in the world does 1/3 mean? Well, remember our fractions. The numerator, I'm going to call that the exponent or the power, and the 3, the denominator, is the root of our radical. So we could rewrite this as the cube root of 36.7. Well, that's not a perfect cube anyway. So I can type it into my calculator as it's written, or like this, because either one will give us the answer. And that answer is going to be, I'm going to round it to 3 decimals, 3.323. It's a point. All right, and then we've got this really strange one here. We've got that 4 raised to the square root of 6. I'm just going to put that into my calculator just as it is. So we'll type in the 4 and the caret, and we'll use that second key so that we can get to that square root, and then we'll put in our 6 and hit enters. And we should get something like this, 29.836. I forgot to circle that one. Ooh, there we go. Alrighty, so we're going to do some graphing here, and that gets us to the fun stuff. So let's take a look at these. As I'm going to first graph f of x equals 3 to the x. So that's going to be, when I do 3 to the negative 2, that is the same thing as 3 to the 3 to the negative 2, you're going to flip it. It's 1 over 3 squared, so it's going to be 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3, just as anything raised to 0 is 1. 3 raised to the first power is 3, and 3 squared is 9. So it's going to look like this, way down here, and it's going to go through there. Something like that. I get a little wiggly here. Let's try the next one. This is less than 1, but it's still greater than 0. So we have f of x equals 1/3 to the x. 1/3 to the negative 2, once again you flip it and becomes 3 squared, so that's 9. 1/3 to the negative 1 is 3. 1/3 to the 0 is 1. 1/3 to the first power is 1/3, and 1/3 squared is 1 to the 1/9. So we're going to have something that looks a little like that. So we have these two graphs, and there's some things, general characteristics of all exponential functions before we do any translations that are in common with all of them. They all have the same domain. That is, these are our x values. And those x values are going to be all real numbers. The range, remember, those are the y values. And that's going to go from 0, but not including it. That x-axis is going to be an asymptote, but it does go all the way to infinity. Every single one of these is going to pass through the point 0, 1. The reason being, anything raised to the exponent of 0 gives you 1. Now we had two graphs. This one, the b, if we have f of x equals b to the x, and b was positive, it was this red one. I'm sorry, the blue one, and it is increasing. If it is negative, that was, or below 1, it was not negative, it's actually between 0 and 1, like that 1/3. That is the red one, and that one is decreasing. So our parent function was that f of x equals b to the x. And we showed two examples where b was 3 and b was 1/3. But then we can start doing some transformations of those. If we are doing a vertical shift, that means we're going to either add a number or subtract a number. So if we add it, that means it's going to shift that up c units. Oops. Up. And if I'm subtracting it, it's c units down. A horizontal shift is going to be that we're going to add or subtract a number in the exponent. So add c or subtract c. If I add c in the exponent, it's going to move it to the left. That number of units. If I subtract a c, I'm going to move it to the right c units. Now if I have a reflection, that means I'm going to have a positive, should have given myself some space here. I'm going to either have a negative, going in front of the b, or I'm going to have a negative going in front of the x. If it's in front of the b, it reflects about the x-axis, which means that if it's going this way, then it's going to go this way. If it's in front of the exponent, it's going to reflect about the y-axis. So if it's reflecting, if it's going this way, then it's going to reflect and go that direction. I can also have a vertical stretch or shrink, and that's by, I forgot to add a space in here again, if I multiply it by c. So if c is greater than 1, it stretches vertically. And if c is between 0 and 1, then it's going to shrink it vertically. And if I multiply x in the exponent by c, that's going to be a horizontal shrink or stretch. So if c is greater than 1, it's going to shrink. I know that feels backwards, horizontally. And if it's between 0 and 1, it's going to stretch it horizontally. So let's take a look at a couple of transformations that we can do. Once again, we'll start with the parent function of f of x equals 3 raised to the x. But remember, our points were 1/9, -1 1/3, 0 1, 1 3, and 2 9. Let me draw that as best I can here. Something like that. Now, if I'm going to take x and I'm going to subtract 1 in the exponent, that means I'm going to move it to the right 1 unit. So this one is going to be 1/9. This one is going to be 1/3. That's 1, and that's 3. And this one is 1/27, so it's really, really small. So it's going to look like this. I have a point here, and 0 1/3 somewhere here. Oops. 1 1 2 3. Here. See if I can get these connected. Oops, it does not cross the x-axis. The last transformation is if I subtract 1 not in the exponent, just down here. That's a vertical shift down. So I would take, this point would be 0 0. Oops, 0 0. This would be 1 2 2 8. This is going to be -2/3, and this is going to be -8/9. So it's going to be down here, come up through 0 0 to 8. So somewhere about here. There we go. So it's shifted down. Down 1. This one is left 1.